All right, so in Unit 5, we've talked about solving by graphing, finding where the two lines cross each other. And next we're going to learn how to solve without actually having to graph it. So we can still find that point, and actually even more precisely without drawing the graph. So our first method for doing this is using addition or subtraction. It is also sometimes called the elimination method. Elimination. Okay. So here's my first example. I have these two equations, and what I want to do is eliminate one of the variables. So I'm going to use addition or subtraction to put these two equations together and eliminate one of the variables. Well, I notice here that I have 2y and 2y, and they're both positive. So if I subtract this whole second equation from the top equation, then I will eliminate the 2y. So 7x minus 3x leaves me with 4x, and 2y minus 2y is 0, so that's been eliminated, equals 18 minus 2 is 16. So now I can divide by 4, and I get x equals 4. Now once I find my x value, I need to go back, substitute it into either of my original equations to find my y value. So I'm going to use the second equation just because the numbers are smaller and it's easier to work with smaller numbers. So 3, instead of 3x, I'm going to actually substitute in this 4. So 3 times 4, right, this is 3 times x, now it's 3 times 4, plus 2y equals 2. 3 times 4 is 12, plus 2y equals 2. And now I'm going to subtract 12 from both sides of the equation. So that's 0. I've got 2y equals 2 minus 12 is negative 10. So now I can divide by 2, and I get y equals negative 5. So then I always have to remember that this is telling me that point or that ordered pair where the two lines cross each other. I can't see where they cross. You know, we're finding that point where they cross. So I need to write it as an ordered pair. So my x is 4 and my y is negative 5, and I write it in parentheses as a point. It's always a good idea to check your answer. So I'm going to substitute this x and y into both of my original equations just to make sure that it works. So 7 times 4 plus 2 times negative 5 equals 18. So I use this top equation, I replaced x with 4, and I replaced y with negative 5, and then 7 times 4 is 28, and 2 times negative 5 is negative 10 equals 18. 28 plus negative 10 is in fact 18. So that worked in that equation. Still have to check it with the other equation just in case I made a mistake. So 3x instead of x, I'm going to put 4, plus 2y instead of y, I'm going to put negative 5, equals 2. 3 times 4 is 12, plus 2 times negative 5 is negative 10 equals 2. 12 plus negative 10 is 2 equals 2. Yes, that works. So now we have successfully found and checked the answer, the solution to that system. We found that point where they cross without ever having to draw a graph. All right, let's do another example. So now we have 4x minus 3y equals negative 26, and we have x plus 3y equals 1. All right, so again, I want these two equations to add or subtract so that I can eliminate, oh, I didn't mean to smear that, so that I can eliminate one of my variables, either the x or the y. In this case, we're going to eliminate y again. It could have been x, it's just a coincidence that both of these are eliminating y. But I notice that if I add -3 plus 3, then that's going to get me 0. So that will be eliminated. So I am going to this time add my two equations together. I have to make sure I'm adding all three terms, and then that will give me 0. So 4x plus another x, remember this is just an x or 1x, is 5x, and -3y plus 3y is 0, equals -26 plus 1 is -25, and then I can divide by 5 and I get x equals -5. Oh my goodness. Okay, so now I'm going to substitute that into either of my original equations. Again, the second one has smaller numbers, it's easier to work with, so I'm going to substitute -5 in for x. So this is just going to be actually -5 plus 3y equals 1, and I'm writing in different colors so you can kind of see how that substitution works. So it should be x plus 3y equals 1, and now I'm replacing that x with a -5, and then I can add 5 to both sides of my equation, and I get 3y equals 1 plus 5 is 6. This is 3 times y, opposite of times is divide, so I'm going to divide by 3 and divide by 3, and I get y equals 2. So now I need to write my answer as an ordered pair, -5, 2, and then I want to check it in both equations. So I have 4 times -5 minus 3 times 2 equals -26. 4 times -5 is -20, minus 3 times 2 is -6, equals -26. -20 minus 6 is in fact -26. And then my other equation, -5 plus 3 times 2 equals 1. -5 plus 3 times 2 is 6. 1 equals 1. So this is one of those places where order of operations, we have to remember that. We're multiplying first, then adding. Okay, so it looks like we did it right. Okay, so we'll move on to another example. The next example, 3x plus 4y equals 11, and 5x plus 2y equals -5. Okay, so for this example, dang it. Oh, no, I got it. So for this example, sorry, I had a moment. 3 and 5 aren't matching up, and 4 and 2 aren't matching up. So I need to change one of my equations to make them match. So in algebra, we are allowed to change equations any way we want, as long as anything we do to one side of the equation we do to the other side. So it's going to stay equivalent, meaning similar or the same, as long as we are doing every operation to both sides equally. So what I'm seeing here is that if I multiply 2y by 2, I will get 4y. So I'm going to multiply this whole second equation by 2. And I'm going to rewrite that new equation over here. So 2 times 5x is 10x, and 2 times 2y is 4y, and 2 times negative 5 is negative 10. So now I've multiplied all 3 pieces by 2. And then this top equation can just stay the same. So I have my 3x plus 4y equals 11. And now, if I subtract those from each other, subtracting, then 4y minus 4y makes 0. So 3x minus 10x is negative 7x. 4y minus 4y is 0. We've eliminated it. And 11 minus negative 10. Well, minus a negative is like adding. We're taking away a negative, or we're adding. So that would be positive 21. Now I'm going to divide by my negative 7. And I get x equals negative 3. Now that I've found one of my variables, I can go back and plug that into either of my original equations. It doesn't matter which one to find my y value. So I'm going to substitute it into the first one. So I have 3 times my x is now negative 3 plus 4y equals 11. So this is negative 9 plus 4y equals 11. I'm going to add 9 to both sides, and I get 4y equals 20. Divide by 4, and I get y equals 5. So now I can write this as an ordered pair and then do my check. So I have 3 times negative 3 plus 4 times 5 equals 11. Negative 9 plus 20 equals 11. 11 equals 11. Yep, that works. And I'm going to do the other one. 5 times negative 3 plus 2 times positive 5 equals negative 5. So this is negative 15 plus 10 equals negative 5. Negative 15 plus 10 is negative 5 equals negative 5. Yep, that works. All right. One more example. Oh no. It's my daughter's writing sample that she had to turn in last week for first grade. 2x plus 3y equals 10. And 3x minus 4y equals negative 2. Okay, so this time I can't just multiply 2 to make 3, or 3 to make 2, or 3 to make 4, or 4 to make 3. So this time I'm actually going to have to multiply both equations to make them match. It doesn't matter if I want to get rid of my x or my y. That's my choice. Seems like we've been getting rid of y a lot, so this time I'm going to get rid of x. So to do that, I'm going to multiply this whole equation by 3, and I'm going to multiply this whole equation by 2, because then these will both be 6. So everything by 3. So 3 times 2x is 6x. 3 times 3y is 9y. 3 times 10 is 30. And here 2 times 3x is 6x, and 2 times negative 4y is negative 8y, and 2 times negative 2 is negative 4. And I always like to go back through. That's a lot of multiplying. Did I miss anything? No, I think I got them all. Good. All right, and now here, 6 and 6, these are both positive, so to make them make 0, I have to subtract. So 6x minus 6x is 0. That's gone. And now I have 9y minus negative 8y. So again, minus the negative becomes plus. So this is 9 plus 8 is 17y equals 30 minus negative 4 is the opposite of negative 4 is plus, so 34. Divide by 17, divide by 17, y equals 2. And then I found my y. I'm going to substitute into either equation to find my x. I'll just do the first one. So 2x plus 3 times 2 equals 10. So I'm replacing the y with 2. Always important to remember which variable it is you're replacing. A lot of people make the mistake of plugging the number in for the wrong letters. You got to be careful with that. So now I have 2x plus 6 equals 10. Subtract 6. And I get 2x equals 4. Divide by 2. And I get x equals 2. So I have my point at 2, 2, and then I'm going to do my check. 2 times 2 plus 3 times 2 equals 10. 4 plus 6 equals 10. 10 equals 10. Yep, that one worked. 3 times 2 minus 4 times 2 equals negative 2. 6 minus 8 equals negative 2. Negative 2 equals negative 2. That one worked. All right, thank you.